There's nothing new in this video, we're just going to bring together the concepts of bias and precision that we've already discussed in other contexts. So we talked about bias in our discussion of sampling, and we talked about precision in our discussion of sampling distributions. However, it's worth putting them both in one place because they belong together as two properties of the point estimates, or the sample statistics that we've just been talking about. So bias and precision are two reasons why a point estimate may differ from its true population value that we're interested in. So let's think about them together, and let's make sure we are aware of exactly what we mean when we use the terms bias and precision. So the bias and precision of a point estimate can be illustrated using this dartboard analogy. So if we consider each of the 7 marks on these dartboards a point estimate, and the middle of the dartboard the true population parameter that we're trying to estimate, in this plot here we've made an unbiased and precise estimate. Sometimes you will hear people use the word accuracy instead of biasness, but I think biasness is much more common when we talk about the results of a study, so I'm going to use the word biasness. In this next plot here, we are still unbiased because our point estimates are centered around the population parameter, but our measure is less precise, as indicated by the wider scatter. Here, our point estimates are more precise, but now they're biased. They center away from the population parameter. And lastly, we have a biased and an imprecise estimate. Not very good at all. So precision concerns the variability of our sample statistic, or our estimate, point estimate. The more precise, the more certain we can narrow down the likely values of the population parameter. Precision comes from sampling variation, and we measure it using the standard error. It's a random component of our point estimate. The equation for the standard error of the mean shows that there may be 2 sources of imprecision, one related to the sample size, for example a small study, a less precise estimate, but another related to the standard deviation. If that's bigger, then our point estimates may vary more, and that's kind of intuitive because you can imagine you'd need more observations to get a representative sample if the variation in the population is bigger. Possible reasons why measures may vary more are random measurement error, for example an imprecise measurement instrument, or something to do with the inherent biological variability of a measure. Consider for instance blood pressure. In that case you could have both measurement error from an inaccurate measurement device and also a lot of biological variability or fluctuation in blood pressure throughout the day and temperature of the room, etc. But our sample statistic will only vary randomly around the true population value if we have not introduced bias into the study. So bias is a systematic component of the sample statistic. It describes how different on average any sample statistic will be from the population parameter. Some sources of bias are related to the sampling process, so-called selection biases. This might introduce systematic bias due to overrepresentation of certain individuals or observational units. Our way of measuring something may also introduce a systematic bias. For example, consider trying to estimate the prevalence of smoking among pregnant mums by asking them if they smoke. Many mums might be reluctant to report a behaviour that is known to be damaging to the health of their baby. Hence, the estimate is likely to be biased towards non-smokers. When we appraise a research study, many of the strengths and weaknesses of its methodology are special cases of these 2 characteristics of point estimates, precision and bias. So they're useful concepts to build any appraisal around.